Elgato's new Stream Deck modules are amazing for makers, easily letting us create our very own projects, like this custom working Stream Deck case. But there's one thing people have been asking Elgato for years. That's right, a wireless Stream Deck. And I'm here to tell you, the wait is over. I'm Finite Singularity, and today we're going to build our very own wireless Stream Deck. In order to build our wireless Stream Deck, we are going to need a few things. The star of the show will be one of the new Elgato 32-key Stream Deck modules. Think of a Stream Deck module as the guts of a Stream Deck, without all of those pesky little extras like a case or a cable, or even any visible Elgato branding. To control the Stream Deck and process commands, we'll need some brains. And we'll get that in the form of a Raspberry Pi 02W. The Raspberry Pi is a tiny computer that runs an operating system called Linux. It provides us with the USB interface needed to connect the Stream Deck module, a Wi-Fi chip to make our project wireless, and a CPU that is capable enough to handle all of the processing we will need to do. Next, we need to power our project. For this, I've chosen this 10,000 milliamp hour LiPo battery. A battery of this size should provide several hours of runtime on a single charge. A couple of things to note. The battery comes with a JST PH 2.0 connector. We will be using this connector as it's quite easy to short out the battery if we try soldering it directly to our controller board. Additionally, this battery has a built-in undervoltage and overcurrent protection circuit, which will be required due to our design. More on that later. Unfortunately, the Raspberry Pi can't charge a battery on its own, and so we will need this tiny battery charging board. This charger module is a 3.1 amp charger and can even convert the battery's 3.7 volt output to the 5 volts required by the Raspberry Pi. However, when the charging plug is inserted or removed, there is a brief cut of power output, which will cause the Pi to turn off. If anyone knows of a good 2 to 3 amp charger board that does not do this, please let me know in the comments below. Thus, to work around this issue, we will attach a power booster to the battery output to deliver 5 volts to the Pi. The power booster takes as input 2 to 24 volts and outputs an adjustable 5 to 28 volts. It has a small set screw that allows adjusting the output voltage. Note that wiring this power booster directly to the battery skips the charging board's protection circuits. Thus, it's important to use a battery that has built-in protection, like the battery we've chosen for this project. Finally, to connect everything together, we will need a few other items. To connect all of our power providing components, we'll need some JST PH 2.0 male and female pigtails. We'll also need a USB-C to micro USB cable for testing, and depending on the size and layout of your enclosure, a USB-C to USB-A cable. Finally, we'll need some Kapton tape to hold things in place and to insulate some areas to prevent shorts. And that's it for our parts list. In addition to these parts, you'll also want a soldering iron and solder, side cutters, and a way to strip the wires. I've left links to all of these parts as well as some of my favorite tools in the description below. Now that we have all our parts, let's start building. Putting the pieces together should be quite straightforward. We'll start off by connecting our battery to our battery charge board. We'll then go from the battery to our 5-volt booster and on to our Raspberry Pi. Finally, we'll go from the Raspberry Pi to our Stream Deck module. With that in mind, let's go to the bench and see how it all comes together. And here is the final assembled circuit. We run the battery to the power board. We then go from the same pads on the power board to our booster. Note that I used a multimeter on the booster's output pads and adjusted the set screw to ensure we're providing exactly 5 volts to the Raspberry Pi. We then route from the booster board to the 5-volt and ground pins on the Raspberry Pi. And finally, we provide a micro USB connection to our Stream Deck. In this case, I've soldered my USB cable directly from the pads on the bottom of the Pi to the Stream Deck. This is to give myself more space when I build an enclosure. If you'd like to do this as well, I'll leave a link in the description on how this is done. Now that the circuit is built, let's do a bench test to ensure everything is working properly. When I plug the battery in, I'm expecting to see the green light on the Raspberry Pi light up, as well as the Elgato logo appear on the Stream Deck. And there we go. It looks like it's all working. Now it's time to build an enclosure. A model was created in Fusion, which then was 3D printed for the Stream Deck case. I started off using the drawing files provided by Elgato of the module to determine the hole locations and size of the module. The Stream Deck module has 4 holes in the corners, and these were used as registration posts to keep the module in place in the case. For the bottom half, compartments were made to hold both the battery and the charging board. Additionally, a hole was cut in the side of the case for the USB-C charging port. After completing the 2 models, they were sent off to the 3D printer. I plan on creating another video detailing how the case was designed and printed. Before you go cramming all of the components into your new 3D printed enclosure, you'll want to install the Raspberry Pi operating system on a micro SD card and place that card in the Pi. The process is made easy by the Raspberry Pi folks, so let me walk you through it. First, you want to go to the Raspberry Pi software website. I'll leave a link in the description. On this page, you want to find your operating system and download the Raspberry Pi Imager. This will make creating your micro SD card quite simple. Once you download and launch the Imager software, you'll be presented with a window that looks like this. You're going to want to first choose your device. We are going to be using a Raspberry Pi 02W. For your operating system, you'll want to go under Raspberry Pi OS Other and select the Raspberry Pi OS Lite 64-bit. And for your storage, you're going to want to take a micro SD card, put it in a reader, and attach it to your computer. Once you've done that, it will show up in this storage list. Make sure you select the correct device here if you have more than one, and click Next. Now we're going to edit some of these settings so that our Raspberry Pi runs as we would expect. So click Edit Settings. Here you can set a host name so you can more easily find the Raspberry Pi on your network. You can set a username and password. And the most important part here is we want to set up our home Wi-Fi here so that the Raspberry Pi can connect to the network. Finally, you want to go under Services and you want to ensure that SSH is enabled with password authentication. This is how we're going to finish setting up the wireless Stream Deck. Go ahead and click Save. And then when it asks if you'd like to apply those settings, click Yes. Now it warns you that it will erase all of the data on the drive, so we want to continue and click Yes. At this point, you can now safely remove that SD card from the reader and place it in your Raspberry Pi. After installing the Raspberry Pi OS and putting all of the components in your enclosure, you should have something like this. A powered Stream Deck that shows the Elgato logo when turned on. Now we just need to install some software on both the Pi and our streaming machine to get everything working. In order to connect wirelessly to the Elgato Stream Deck software, we are going to use something called USB over IP. A company called Virtual Here has a great USB IP software which is free for uses like this. So let's get it installed. We are going to begin by connecting to our Raspberry Pi via something called SSH. On Windows, you can use PuTTY or the terminal. On Mac OS, you can also use the terminal. I'm going to SSH into that Raspberry Pi. If you need more information, there are plenty of tutorials out there on how to use SSH. Typically, you can determine the IP address of a device on your network from your router's admin panel. So now that we have SSH'd into this machine, we are going to paste a command here, a big curl command that comes from the virtual here folks. And this command, which I will put in the description below, will install everything you need on the Raspberry Pi. So paste the command in, hit return, and let it run. And like that, our virtual here service is installed and will be restarted every time we restart the Raspberry Pi. Next, go to the Virtual Here client page. Again, I'll post the link in the description below. And for your operating system, download the Virtual Here client. In this case, I'm going to download the Windows client. Here's where it gets exciting. Run the Virtual Here client that you just installed on your streaming machine. I've got both the client and the Stream Deck software open so that we can see the magic happening. If everything is working properly, you should see something similar to this. Notice the Stream Deck XL USB device. All we have to do is double click it and it'll connect to our PC. You see that the Stream Deck software picked it up and populated all of the default buttons. Congratulations, you now have a working wireless Stream Deck, which can run for several hours on battery power and can be charged with a USB-C cable. Now there's a few things I want to fix on this project, mostly related to power and the ability to gracefully shut down the Raspberry Pi with a button, but that'll have to come in another video. I hope you all enjoyed the journey of building a fully functional wireless Stream Deck. Remember way back when Stream Decks had wires? So long ago. But Elgato, until you release one, this version is our only hope. There's something so satisfying about being able to trigger effects without any pesky wires getting in the way. If you enjoyed this content, please hit that follow button, as I've got a lot of fun projects and tutorials I'd like to post. And be sure to drop by my live stream on Twitch, where we do all sorts of nerdy streaming, builds, and effects. And with that, we'll see you all in the next video. What are you doing still watching? The video's over. Go build yourself a wireless Stream Deck. I gave you all the directions on how to do it. It's fun, I promise.